It is also a good thing to take note that since there are forces due to the convection current, we can classify these forces into ridge push and slab pull. Okay, so let's look at how it would look like. Let's just quickly shift over to the phone. There. So again, there will be two forces, and that will be ridge push and slab pull. Okay, let's just quickly illustrate both of them. So here I will draw again the crust. Later na lang. So according to the previous chart, it was going to be 4,400 degrees Celsius, right? 4,400 degrees Celsius. That is really, really hot. And at the surface, near the boundary is going to be 870 degrees Celsius. So hot rocks from the lower mantle are going to rise, and cold rocks from the top of the mantle are going to sink. Okay, so same movement is going also to happen over here. Okay, so let's say that hot rocks from the mantle again rise, and cold rocks from the mantle sink. Here too, hot rocks from the mantle rise, and cold rocks from the mantle also sink. So another thing also good to take note is that there is a layer here on top. Of course, is going to be the crust, but below the crust there are sub layers. Okay, there is let's just move on from the mantle. On the top of the mantle there is a plasticky like layer over there that is called as the asthenosphere. So let's just name it the asthenosphere. Asthenosphere. Now this layer here is very, very fluid layer, almost liquid like layer, and this here is what mainly is mainly being influenced by the convection current in the mantle, and this here is what moves the layers on top. Okay, now there is another layer here on the that is also part of the mantle. It's just named as the upper part of the mantle, just upper mantle, that is solid. Okay, so this here is still mantle, but it is classified into two more layers. And then the top of the layer, we will have the crust over here. Okay, so this is where we live. Yay, there is Sir Ivan, very happy. And then there are some buildings, and then there is Sir Ivan's house. Okay. Now what there is also another layer that you most probably have known, and that it is called as the lithosphere. The lithosphere is actually the crust and some part of this solid upper mantle combined. Sir, ano yan, sir? It is because the crust and the upper mantle, together known as the lithosphere, they move together. Okay? The crust and the upper mantle, they are called as the lithosphere because they move together. That's why they are called as another separate layer. Okay, so as we would observe here in our illustration, there are some parts that are going to collide, or some such as this one. Let's just put some arrows over here. There, those are arrows that will collide. So these are hot rocks. I mean, these are cold rocks that are sinking, and then these are hot rocks that are rising. Okay, so what happens here is that there is going to be a collision, and then there is going to be some influence to the top layers, and this is how it's going to look like. Okay, So since diba, cold rocks were sinking and then hot rocks were also rising, it will influence the asthenosphere and the lithosphere. Again, the lithosphere is the crust and some parts of the upper mantle. There will be something that will look like this. Okay, most probably you've already known this as subduction, right? So this lithospheric plate, this is a lithosphere. This lithospheric plate here will sink. Right? It will sink. And this plate here will just stay put. But most probably it will also collide with the other one. Okay? So this process here is called as subduction. The sinking of one tectonic plate below another, and there is a force that is involved here. The force is called as the slab pull. Okay. This here is the slab pull. The slab pull force is created because of the convection current. So convection currents in the mantle create slab pull force in order to sink a tectonic plate, and the process of the sinking is called subduction. So subduction is going to be the process, and slab pull is going to be the force that causes this. Okay? Now, we discussed a while ago that there are actually two forces. The other force is called the ridge push. So if you were to go back to our illustration over here, you will notice that these rocks here are also rising and these rocks here are also rising. So, how will that look like, sir? This here is how it will look like, young child. So, rising siya there. So what will happen is that there will also be another boundary here. Okay, again, this here is the lithosphere. Lithosphere is upper mantle and crust. What will happen is that these two plates are going to be going away from each other. Okay, and the force that is called here is going to be ridge push. Ridge push. Again, this here is the force made by the convection current of the mantle. Okay, so these two plates are going to be moving away from each other, because of the ridge push. Right? There's also a force that is going to push it up over here. Okay, now this here is what happens, okay, in our tectonic plate. So let's just quickly go back to our tectonic plates. Ito na lang muna. So this here is, okay, please play. This here is going to be ridge push there at the center, and at the two corners is going to be slab pull, where subduction also happens. Okay? So, these tectonic plates are actually experiencing those kinds of movement. In some of these plates, there will be subduction, there will be collision, and in some of these plates, there will be diverging, going away from each other. And that is one of the main reasons why these tectonic plates are moving. If we were to go back a few more slides over here, it's hard to determine which ones were actually... we can notice that here at the middle of the Atlantic Ocean, the two plates, right, the North American plate, the South American plate, and the African plate are going towards each other. Okay? And then some of them are actually also converging with each other, or colliding, or having a collision. Okay? And that will be all for our first video. Tune in to the second video for more explanations.